Hello everyone, welcome to the channel, and today we are going to unbox a huge mailbag from China. So first of all, I purchased each of these boxes from Aliexpress, and this was my first experience with the company. Although I've purchased a lot of stuff from other Chinese e-commerce websites before, like Banggood and GearBest, I wanted to try Aliexpress this time. Some of these boxes are sitting here at my bench for the past few days, but I was kind of waiting for all of them to be here before making this video. So I have already opened and tested some of them, well, pretty much all of them, to see if they are okay or not. But to show you guys what to expect when you buy these parts from AliExpress, I put the parts back into their respective boxes. So what is this video about? First, I wanted to show you guys that if you're getting a decent quality electronics for a cheap price from China, you should probably buy it. Second, you don't buy these things every day, so little bit research doesn't cost much. And third, obviously for content purposes. Now this is not an in-depth review video, so I'll go pretty fast because there are a lot of electronics to cover here. If you want a detailed review for any of these, then just let me know in the comment section. Alright then, what should we unbox first? I suppose the most important part of any electronics bench. A DC power supply. This cost me around $80 on AliExpress. I chose FedEx for delivery, which cost me around $20 shipping charges and extra $20 for custom duty. A power cord, and a test cable. Let's take the supply out of the box. I must say this power supply was neatly packed when I first opened it, and I'm impressed by their packaging standards. So thumbs up to the seller. What else do we have here? A manual, I guess. How to use the power supply and other info can be found here. I'm going to skip this for now. One more test cable and some alligator clips. So there is a manual, 2 test cables, bunch of alligator clips, and a power supply cord. I'll probably fast forward some parts, but this video will take whole day. This is PS3010DF power supply made by the company Longvi. It is rated for 30 volt and 10 amperes maximum. On top left is the logo of the company Longvi, DC power supply 3010DF. Green color button is the on off switch, 3 output terminals, and here we have the voltage course, voltage fine, and current course and current fine adjustment knobs. On left we have 4-digit LED display for voltage, current and power. I'll talk about the constant voltage and current LEDs later on. At the back side it has a cooling fan, AC input is from here. It also has a small switch to switch between 220 volt and 110 volt input because this power supply is compatible with both, but since it's already in 220 volt position, I'll leave it as it is. This says it is ROS Combined certified. Well, we never know. So guys, this is the page from where I purchased the supply. It costs around 83 US dollars. Some of the specifications are mentioned here. It have a 4-digit LED digital display. It also has a USB interface of 5 volt to ampere, so you can use it to charge your 5 volt stuff. Now items you get with the supply are listed here. Next we have product description. This is the USB interface mentioned above. So you can plug your mobile phone here to charge it. This shows the backside of the supply. Comfortable handshake? What does that even mean? That's it. Now let's go to the bench. I just noticed that the power cord which came with this power supply does not have earth pin. And I don't know the reason. Maybe they expect us to fit a connector there. Anyway, I have an extra power cord, so I'll use it to power the power supply. Okay, now power supply is connected to the main supply. Let's turn it on. All three values are 0 right now as indicated by the displays. Before operating, I'll connect the alligator clips which came with the power supply to the output terminals. Quality of these alligator clips are not so good, but what can you expect when you're getting so much for $80? On the power supply are there 3 terminals which are positive, negative and ground, which might confuse some beginners out there. The voltage displayed on the display is always between positive and negative terminal. The ground terminal is actually internally connected to the earth terminal, so you can get both positive and negative voltage from the same supply. Now if I increase the voltage using coarse adjustment to see the maximum voltage this can output, and then fine adjustment, the maximum voltage limit is reached, which is 32 volt. That means this power supply can output around 32 volts maximum. There's a green LED glowing which says CV, which means constant voltage. Right now we are setting a constant voltage output which can be set anywhere between 0 to 32 volts. But what exactly constant voltage and current means? Let's find out. I'm adjusting current knobs to maximum and the output voltage to 5 volts. I'm using a 12 volt DC motor as a load. If I hook it to the output terminals, on the display you can see voltage is still around 5 volts, but current is reading 350 milliampere and power is around 2 watt. Now what if I increase the load by holding the shaft? So the voltage is still constant but the current is increasing because since we set the voltage to be constant, to get more power the current must increase. There is no other way. See how the voltage is not even flinching but current is increasing. That's called the constant power supply. Now let's see the constant current operation of this power supply. Okay, the voltage is set to 2 volt right now. The supply is still in constant voltage mode. I'll adjust the current knobs to any arbitrary positions. Increase the voltage to 6.5 volts maybe. Okay, so current is set to a very high value, so let's decrease it so that we can hit the constant current point. Not 0, slightly more. There it is, at a constant current of 260 milliampere indicated by the red LED. On changing the load, the current is still the same, but now voltage is fluctuating. If I increase the current, it's still in constant current mode, which means the constant voltage which was set to 6 volts is still not reached. Let's increase it more. And now the supply set to its constant voltage mode, which we set to around 6 volts earlier, because there is no way for the supply to increase current without increasing the voltage. The power displayed here is just a multiplication of voltage and current because it's DC. So guys, this is a short demo of PS3010 DF power supply from Longvi. I purchased this for around $80. All links are in description as always. Next we have another big box. This was delivered by Aramex in 15 days from China to India. It says Handtech. Many of you must have guessed by now what it might be. This is a digital storage oscilloscope. This DSO or digital storage oscilloscope is from 5000 series manufactured by Handtech. Gross weight is 2.5 kilograms and net weight is 2 kg. The box of this oscilloscope is quite impressive. The scope is DSO 5102P 100 MHz 1 GHz sample per second 2-channel oscilloscope. They have another version also, exactly similar. The only difference is of bandwidth. This one has 100 MHz bandwidth, whereas that one has a bandwidth of around 200 MHz. I think it is called DSO 5202P. Some says you can hack this oscilloscope to get 200 MHz bandwidth. The oscilloscope is nicely packed. What else do we got here? A power supply cable, probably like the last one, without earth terminal. A USB cable. Two oscilloscope probe kits. 2 of them, one for each channel. So they give you 2 probe kits with the scope. Next we have a part list that came with the oscilloscope, warranty card and a CD. Inside the CD we have a user manual and software which displays the waveform on the PC. Maybe we'll take a look at it in the end. We don't need any of these at this moment. I guess one probe is sufficient for now. This cost me around $240 including shipping charges, which is pretty cheap considering the features you get with the scope. So for beginners, I think it is a great scope, and for those also who just wants a cheap but decent quality oscilloscope on their bench. What's best about this oscilloscope though is its TFT LCD. It's around 7 inches. Can you believe that? For just $240. Handtech DSO 5102P. It is listed here for $168 and I got it for $240 including shipping charges. but from Amazon it would have cost me around $350. So I saved $100 right there. Now some features of the oscilloscope: 100 MHz bandwidth, 1 giga samples per second. It has a 7-inch color display. One of the reason I purchased it. Record length up to 40K, so I guess it meets my requirements. 4 math functions including FFT, another reason to buy it. And you also get a software for the PC. Screenshot of the waveforms captured by the oscilloscope. Some oscilloscope images and the components you get with the oscilloscope. And at last we have the detailed specifications of the oscilloscope. So please go through these before buying the oscilloscope. Okay, so now that we have it on the bench, let's take a closer look at it. On top left it says Handtech DSO 5102P, and here it says 2-channel digital oscilloscope, 100 MHz, 1 giga samples per second. At the back of the scope is some safety warning and rating of the oscilloscope. Frequency anywhere between 45 to 440 Hz, and input voltage can be between 100 to 240 volts maximum. That means you can connect it to 110 volt as well as to 20 volt. An input voltage port and USB port to connect the scope to a PC. Now let's turn it on and see how much time it takes to boot. Wow, around 7 seconds. That's pretty fast. Some buttons have LED in them to remind us that they are pressed, like here red means stop and green means run, which is really cool. This is the channel 1 BNC connector terminal, similarly for channel 2, and an external trigger terminal. Note that channel 1 is yellow and channel 2 is blue in order to differentiate them from each other and their waveforms also. Here is the Oscilloscope Probe Kit. Let's see what we have in here. A manual. It says probe can be PP80, 150 or 200. Ours is PP150 because this is a 100 MHz oscilloscope. So PP80 and 200 would be for 60 and 200 MHz respectively. Some electrical characteristics: attenuation, compensation range, and bandwidth, etc. And some physical characteristics like weight and length of the cable. In the kit, you also get a small screwdriver for probe compensation. Now in this video, I'll not show you how to do probe compensation or self-calibration of the scope. Well, they are pretty easy to do anyway. We have some marker rings of different colors in the kit. Marker rings helps to identify different channel probes. They are easy to install on probes. Let's take a look at the probe. This side goes to the waveform you want to capture. There's a small hook which makes it easy to attach the probe. There is an attenuation switch here. On 1x the maximum frequency limit is 5 MHz, whereas on 10x the limit is 100 MHz. But remember, the attenuation settings on the probe should match the attenuation settings on the oscilloscope, else you would get weird or incorrect measurements. The black alligator clip is connected to ground of the circuit you are measuring, and it is internally connected to the earth terminal of the AC input. PNC connector. Some specifications of the probe. See, it is PP150 probe. Let's connect it to the oscilloscope real quick. Okay, the probe is connected to the scope. Every scope has an inbuilt signal generator for compensation purposes. This one has 5 volt 1 kHz SqureWave signal generator. I'll use this SqureWave generator to explain all the basic function of the oscilloscope. This goes here and then this to ground. Let's set auto set, which not only automatically triggers the waveform for us, but also set vertical and horizontal scale to display a stable waveform. Though it's not a good idea to use auto set always, for square waves it works perfectly. On bottom of the screen, some properties of the waveform is displayed. Let me zoom a little bit. We have V peak to peak, mean, frequency of 1 kHz, and the time period. This is volt per division adjustment knob to manually adjust the volt per division. Maximum is 5 volt per division. And this changes the vertical position of the waveform. You can see at the bottom it is displaying the current vertical position. -1.80 -400 millivolt, -200 millivolt, and it's back to 0 volt position now. Similarly, for horizontal adjustment, time per division knob is there and a horizontal position knob. Now there's this symbol near some of the knobs, which means they have a push button functionality. For example, the horizontal position of the waveform will be set to default or 0 position if you press this knob. Similarly, vertical position can be set to default or 0 volt by pressing this. We have different menu options here: cursor, save, utility, measure, acquire, and display. Measure gives us the different properties of the waveform. You can see them here: maximum, minimum voltage, pulse width, rise time. But the cool stuff is displayed when this button is pressed after pressing the measure button. Yes, these all are the properties of the waveform displayed by the scope. I guess there are total 32 measurements here: fall time, rise time, bandwidth, and much more. Well, some of them cannot be determined for a square wave. That's why there is a question mark over some of them. Now for second channel, probe terminal, and vertical control knobs. But in order to see second channel, you need to press this button. Blue LED indicates that the second channel is active. What else do we have here? These all are trigger controls. To access trigger menu, you have to press this button. Let's take a closer look. Type, source, slope, mode, and coupling. First type of triggers. The default is edge triggering, but we also have video, pulse width, slope, overtime, and swept trigger. Triggering can be set for channel 1, channel 2, and external trigger. But I don't have an idea about the remaining two. Now you can set when you want to trigger the waveform at a rising or falling edge. Next we have slope select, triggering mode, auto, and normal. And finally coupling, DC and AC coupling, noise reject, high frequency reject, and low frequency reject. Now let's take a look at the other menu options. I'm not going to go in much detail though. Acquire menu is for different data acquisition modes. Next we have couple of display options like type of waveform representation, vector or dotted, contrast, which sets the brightness of the LCD. Now at the bottom it shows page 1 of 2. To access page 2 options, press F6 or mode. More display options here like waveform intensity, which sets the brightness of the waveform on the screen. I can turn the menu off to see the full waveform. Next is cursor mode, which is super helpful for manual measurements. We have time and voltage measurements and track the waveform option. Let's select time. There are two cursors here, start and end cursor. To move the cursor, and knob V0 moves the cursors around. First we have to select the individual cursor from select cursor menu. Right now start cursor is selected. Similarly select end cursor. So time in DT, which is the time between the cursors, is displayed at the bottom of the screen. Similarly for voltage, you can also select both cursors together and move them together. Again, the voltage difference is displayed at the bottom. You can access horizontal menu from here. Next we have math menu, which is really cool as we can perform various math functions between the two channels displayed by the purple waveform. Addition, FFT, division, multiplication, and subtraction. Note that channel 2 is off right now. The FFT or fast Fourier transform is one of the feature which you can never get at this price in any other oscilloscopes. We can analyze the channel 1 signal in frequency domain using FFT. This topic needs a whole video of its own, so I'll just skip it for now. We can access auto set menu by pressing F6. Right now it is set to multi-cycle, that's why we have bunch of similar waveform cycle on the screen. Single cycle displays single waveform cycle. Same way rise edge and falling edge. Notice the sound oscilloscope is making. The bunch of relays inside the oscilloscope are resetting the auto set options. Let's bring it back to the default auto set. If we push the help button, it displays the help menu which provides topics covering all the oscilloscope options. Default setup button will bring the oscilloscope to its default settings. And save to USB function button captures the waveform displayed and saves the screenshot to the drive connected here. Okay, so I guess I have covered all the basics here. Now I know I went pretty fast and may have skipped something. Maybe I'll do a detailed review of this oscilloscope in near future. Anyway, let's move to the next parcel. Next, I have a small yellow box here. This box contains a signal generator. It comes with two packages. One is signal generator itself and the other is acrylic casing for the signal generator. It has some screws also to fit the generator inside it. I purchased the one with the casing, but you can get a similar generator without the casing for a lower price. I got this one for $50 from Aliexpress. As you can see, it's quite small in size and looks nice also. There are two potentiometer knobs inside for smooth rotation. Both are of different colors. One is blue in color and other one is red. They are for amplitude and offset knobs respectively. This is a DDS or directly digital synthesis signal generator. Now I'm not going to assemble the acrylic case for the generator in this video. Offset voltage can be set using this knob and amplitude using this. Offset basically adds the DC voltage on top of the varying signal generated by amplitude knob. There are total 5 push buttons here for different functions. The middle one is to switch on or off the output waveform. Right and left push button increases and decreases the frequency, whereas top and bottom one cycle through the different waveforms. On top right are two BNC terminals. There was no BNC connector in this kit though. One is for normal DDS frequency output 65 kHz maximum, and other one outputs high frequency up to 8 MHz. It takes input voltage up to 9 volt maximum from here. Backside of the generator have couple of SMD ICs. The PCB is yellow in color, which gives a nice look to the generator. And for display, we have a normal 16:2 LCD display. Now I'll connect it to the supply. The signal generator costs around $14 US. Some features of the generator. It says TDS frequency range is between 1 Hz to 65 kHz, whereas the high speed frequency range is up to 8 MHz but in steps of 2 MHz. Step frequency, I think there is some error here. It is 100, 1K and 10K. Automatically recovers the last time after power supply. So what they want to say is that it saves your last frequency settings even if power is turned off. Next is offset, which is 5 volt maximum, 5 volt peak to peak maximum, amplitude between 0.5 volt to 14 volt peak to peak, output impedance, and some high resolution images of the generator. But this shows the generator inside the acrylic casing. I've connected the signal generator to the same power supply I unboxed earlier. The voltage is set to 8 volts. Let's turn on the power supply. Note that there is no on-off switch on the generator board. LCD is on. It shows sine waveform of 1 kHz frequency, but in off condition right now. This push button turns on the output. Press it again and it turns the output off. You can change the output frequency only when the output is off. This button decreases the frequency and this one increases it, which is quite opposite to normal. I don't know why it is so. To access different waveforms, press the top or bottom button. High speed frequency generator for this output. Other one is for normal signals. Next is noise signal. Next is frequency step. This changes the steps in which frequency changes when left or right button is pressed. Here also it's quite opposite to the normal. Next is ECG. Reverse, sawtooth, triangular, square, And we are back to the sine wave. All is good except this. Maybe a hardware issue, or maybe they did it intentionally. We never know. The amplitude and offset can be set using these knobs. The signal generator is now connected to the oscilloscope through a BNC connector cable and to the 9-volt supply. I'll turn on the supply now. Sine wave is selected right now. Even if you switch off and turn it again, it will keep the last settings. Turn on the generator output. I'll adjust the voltage and time base. The oscilloscope shows frequency of 1 kHz and V peak to peak of 14 volt, which is maximum this generator can output. I can adjust this using amplitude knob. And offset using offset amplitude knob. Offset limit is 5 volt peak to peak. It has started to clip the waveform now. The oscilloscope is in DC coupling mode. That's why it is displaying the offset voltage also. Let's try to bring the offset exactly to 0 volt at 10 volt amplitude. To change the waveform, first turn off the output and then select the waveform and turn the output on again. This is a noise signal. ECG signal. Reverse sawtooth. Sawtooth. Note that frequency is 1 kHz for every waveform. Triangular and square. I have set the frequency to 920 Hz now. Let's increase it in steps of 1 kHz. 1.9 kHz. Around 11 kHz now. The maximum frequency it can output is 65,565 Hz. Let's bring the frequency to that value. Oscilloscope is showing 65 kHz. Not bad. I can also increase the frequency in different steps now to bring it to the exact value. I've connected the high-speed output of the signal generator to the oscilloscope now. Let's turn the generator on. Frequency is set to 1 MHz on signal generator. Oscilloscope is also showing 1 MHz. Although there is huge voltage spikes at the transition levels. If I change the frequency now, it will change in steps of 2. 8 MHz is maximum. Voltage spikes are more or less the same. And now 4 MHz. Although we are setting high frequency square waves, but there is some huge voltage spikes and noise in the waveform. Now I have connected the oscilloscope back to DDS generator output. Specification says that the lowest frequency it can output is 1 Hz. I want to see that on the oscilloscope. The frequency is now set to 1 Hz. Let's turn the output on. The frequency on the oscilloscope is around 950 mHz on the yellow strip near to mean voltage. But at the bottom, it's not able to display accurately. I'll try 10 Hz now. Okay, now it is displaying the frequency correctly at bottom frequency also. Bye bye. Let's use the measure menu. Let's bring the frequency to 1 Hz again. And now the frequency is displayed correctly, around 1 Hz at both places. On the function generator display, frequency is 1 Hz. Since this video is already too long, I will unbox rest of the electronics in the next part of this huge mailbag. But at least we have unboxed the 3 important tools of any electronic bench: power supply, oscilloscope, and a signal generator. So see you then, and remember, electronics should be your first love if you want to succeed.